This is geometry. We're working on exploring properties of diagonals of these quadrilaterals. The definition of our diagonal: a segment that connects non-adjacent vertices. That would be a diagonal. So with a partner, you can cut them out or you don't have to cut them out. Whichever. I've reprinted them off because in this packet they are on the back side of another sheet. So here you could cut these out individually and work on them, or you could just keep it right on your shape. Draw the diagonals. So if we were to draw the diagonals, this would be one example. I would suggest putting your pencil on a vertex, pushing the ruler up against it, slide the ruler so it pretty much lines up with the next vertex so you can draw your diagonal in. A diagonal connects non-adjacent vertices, not the vertices next to each other. That would be a side if you connected those vertices. Non-adjacent means the ones that you got to go through the inside of the shape. We also can draw in the other diagonals. In this situation, we draw them both in. So those are our two diagonals. Then find out, there's actually 4 facts, 1, 2, 3, and 4, about the diagonals is true for each of the 6 shapes. Use your ruler to find out if the diagonals have the same midpoint. Well, if we zoom in tight on this particular one, and we do some measuring, this looks to be approximately like 3.3. I'm using the centimeters or millimeter part. So these would be centimeters. And this is about 3.3. This direction, that looks like 5.3. And this one, 5.3. So you can tell that the diagonals are not the same length, but each diagonal is cut in half. This diagonal half is the same as that diagonal half. This one is the same as this one. So the diagonals bisect each other. That's one thing we know for sure. Use a protractor or a corner of a piece of paper to determine if the diagonals are perpendicular to each other. Let's see, you couldn't read that at the same time. I was writing it. All right, use a protractor, a corner of a piece of paper, to determine if the diagonals are perpendicular to each other. So if we take our piece of paper, we line up the corner of our paper with where the diagonals cross, you'll see that it clearly does not square off with that other diagonal piece. So that means the diagonals are not perpendicular. It does not form a right angle for this shape that we have drawn here. Use a ruler to determine if the diagonals are equal in measure. Well, we've already done that. This would be 10.6. This would be 6.6, not the same length. Use your protractor to determine if the diagonals bisect each pair of opposite angles. So we can get a protractor. And you want to put this point at the vertex, and you want to turn it so that this side is running down the edge, the side of your quadrilateral. You've got to be detailed on getting that to line up. If we look here, we're going to start at the 0 angle. 0, 10, 20, 30, 40, 50, 60, 70, maybe 71. That was 71 degrees. Now we'll come over here and we'll try the same thing. I'm going to put the point at the vertex. I'm going to run the side down the edge of the diagonal. Line it up. Take your time. And start with the 0. So 0, 10, 20, 30, 40. That looks just about 45. So they are not the same measure. Right? They nowhere close. Are they? Is this diagonal bisecting that opposite angle? If you want to do the other ones also, here we got 70. That looks a little bit bigger. That's weird. 71, 72. So this looks closer to 72 degrees. And then this one looks just about 45. All right. So there's a little human error in this one. These are supposed to be exactly the same. I got those to show the exact same. I got those to be super close, but it didn't quite seem to be the same. Right, I guess it's arguable if that is 71 or 72. Kind of depends on how you measure it. You could call that 72 if you wish. Okay, so this angle matches that total angle, but the diagonal does not bisect it. That was pretty clear. And you could come on over and check out the other one. Put the little pointy, run the edge down, the diagonal if you wish, and you start with the 0, 10, 20, 25, 26. It's about 26, 27, maybe 26.5. Then you can do it again. Put your little pointy at the vertex. Start at the 0, 10, 20, 30, 40, nope. 10, 20, 30, 35, 36, maybe 37. And you can tell that if this one adds up to be 117, this one is adding up to be 63. And yes, that actually makes 180 degrees. That's kind of cool. That worked out. That's what we would expect. And if you wanted to try it again, you could see here 0, 10, 20, 25, 26. Not surprised about that. That should be the same. 0, 10, 20, 30, 35, 36, maybe 37. It's hard to tell. Keep them matching close to each other. Okay? So this shape is called a parallelogram. Parallelogram. So here on our chart, we could come into a parallelogram. The diagonals have the same midpoint. Yes, they do. Diagonals are perpendicular. No, they weren't. Diagonals are congruent. No, they weren't. Right? One was 10.6, another one was 6.6 in total length, but they were bisected. They were cut in half. Diagonals bisect opposite angles. The opposite angles were not cut in half. 26 and 37, not the same. 72, 45, not the same. So in terms of the diagonals, that's what happens in a parallelogram. Now you can continue and go through with the rest of the shapes. You have a kite. You have a rhombus. You have a trapezoid, probably closer to an isosceles trapezoid, a rectangle, and a square. And you can go through and test those out. After we get done with those, on the very back, there is a list of true and false questions. All squares are rhombuses. Is that a true statement or a false statement? All squares. Well, I know a square has right angles and equal sides. Rhombuses have equal sides. So all squares have equal sides. That's true. So this is going to be a true statement. All quadrilateral are, if a quadrilateral is a parallelogram, then it is a rhombus. So what this is saying is that every parallelogram has all equal sides. Well, this here is a parallelogram, and yes, it has equal sides. This here is a parallelogram, and no, the sides are not equal. Opposite sides are equal, but not all the sides are equal, and that's what a rhombus is. So that would be false. And that's how you have to think about these when you go through a true and false. You really got to take time and concentrate on the wording. What does it mean? They're not really fast answers. You got to think about them and check the details.